If this series converges, which of the following must be true? Let's start by looking at A. I feel like this is the most likely wrong answer people will choose. Why? Because by the ratio test, if the limit of some series whose terms are a sub n, if the limit of the n plus 1 term divided by n term is less than 1 as n approaches infinity, and it is, then the series with the term a sub n converges absolutely. The operative word there, though, is absolutely. We don't know that this series is converging absolutely. We only know that it converges. So if it's not converging absolutely, then this isn't going to be true. That's how we know that A can't be the right answer. So let's take a look at B. We can just consider this geometric series. This geometric series whose first term is 2, whose common ratio is a half. This term and this term are terms whose absolute values are not smaller than 1, and yet this series converges because the R value is only 1/2. So, for a converging series, the terms don't all have to be less than 1 away from 0. So B is definitely not the right answer. Let's take a look at C. Well, for that, we can just look at our counterexample in part B. Here's a converging series, and does it add up to 0? No. This converging series adds up to its first term divided by the difference of 1 and its common ratio, R equals 1/2, which is 4. So this doesn't have to be true. We can rule out C. What about D and E? Let's wrap this up. Well, this isn't true because you can just factor n out in front of the summation symbol. And since we know that the series a sub n converges, if you take what it converges to and multiply by n, that's a finite value. So we know that this series also converges, in fact, to just something that's n times bigger than what this series converges to. It does not diverge. So by the process of elimination, we know the answer has to be choice E. And this is just multiple choice. So by process of elimination, we've got the answer. It's E. But let's suppose we needed to explain this, maybe in the FRQ section. Then, since we know that this series converges, we can prove that this series converges using the direct comparison test with the known converging series. How does that work? We just have to show that this term of this series is always smaller than the term of this series. And it's clearly true because the n values are 1, 2, 3, etc., which means that this positive a sub n value is being divided by a whole number that's 1 or bigger, which makes it definitely smaller than a sub n itself. There you have it. Problem number 90 must be E.